Welcome to today's podcast on covalent bonding. Covalent bonding are chemical bonds between atoms when they share electrons. Oftentimes, nonmetals will share electrons, especially those in group 14 that have 4 valence electrons. 4 valence electrons, it's harder for them to get to 8 by ionic bonding. They either have to give away 4 or take 4, so they often find it's easier just to share electrons. Here is an example from group 14, carbon. Carbon has 4 valence electrons, so these blue electrons are carbon's 4 valence electrons. And again, it would like to get to 8. So to accomplish that, it can share 1 with hydrogen. And then carbon, you can see when they're sharing, carbon now is at 8. And hydrogen, with its one valence electron, sharing 1 from carbon, it can make its energy level full at 2. And again, carbon's energy level is full as 8. So again, sharing those electrons help them each get to the energy level they'd like to be at. Hydrogen at 2, carbon at 8. And the next example we'll look at is carbon dioxide. So looking here at carbon again, and this example, they actually show us the inner electrons. So again, the first energy level has 2 electrons for carbon, but then 4 valence electrons. So again, 4 valence electrons for carbon, and it would like to get to 8. It can accomplish that by sharing some with oxygen. Oxygen, again, you can see it has 2 electrons in its first energy level, and then 2, 4, and 6 in its outer valence electron, or outer energy level. There's 6. And it would like to get to 8. So it can again accomplish this by bonding covalently with carbon. So carbon shares its 2 with that oxygen, and oxygen shares its 2, and it can get to 8 on that side, and then similarly it does the same thing on the other. And when we're sharing 2 electrons, that's a double bond. So here the carbon is sharing 2 electrons, oxygen was sharing 2 electrons. Here we're going to look at a triple bond. So nitrogen can bond to itself, and again, this is a nice example where it's showing us again the inner electrons in that first energy level. We have 2 of them, but in the outer energy level, or the valence electrons, nitrogen has 5. So it's got 2 over there and then 3, and again it wants to get to 8. So if it shares 3 with nitrogen, one nitrogen shares 3, the other nitrogen shares its 3, then they're sharing 6 in the middle, and they have those other 2 on the outside, so that helps them get to 8. So we've got 2 there, and we're sharing 6 in the middle, we get to 8. And when we're sharing 3 electrons from each side, or sharing 6 in total, that's a triple bond, a triple covalent bond. Dinitrogen is an example of a nonpolar molecule where the electrons are shared equally between the 2 nitrogen atoms. Now we'll look at a water molecule. So hydrogen each has 1 valence electron, and they would like to get to 2, so they're going to share 1 of oxygen's so that they can get to their energy level full at 2. And oxygen has 6 valence electrons, so by sharing 1 of each of hydrogens, it can get to 8. But this is an example of a polar molecule where they don't share those electrons equally. So there's an unequal sharing of electrons that gives one end a slight negative charge and one end a slight positive charge, because again, they're not sharing those electrons equally. Again, those electrons are getting pulled closer to oxygen. It's like tug of war, and oxygen is just pulling harder. So it's got more things, more protons and more electrons, so it's tugging harder. And when we get those electrons, when they're pulling closer, the electrons have a negative charge, so that gives it the oxygen and a negative charge, and it gives that hydrogen, which they're further from it, it gives it a positive charge. scientists use the Greek prefixes to indicate how many atoms of each element are in a covalent compound. So if we have one atom, we might use the Greek prefix mono to indicate one atom. If we have two atoms, we use the Greek prefix di. 3 atoms, tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa, and etc. So let's practice naming a few covalent compounds. To begin with, I look at the subscript and I see that I have 2 nitrogen atoms and just 1 oxygen. So I would name this dinitrogen oxide. For the next one, again, I look at how many atoms I have of each. I have 1 nitrogen, so just nitrogen, and 1 oxygen, so oxide, or this is where I can use the prefix monoxide. Again, monoxide, sometimes the mono is not used, it's just implied that it's 1, but sometimes they do use it like carbon monoxide to stress that it's just 1 atom of oxygen. Next one, I have nitrogen dioxide, because there's 2 atoms of oxygen. And the last one, we have 2 atoms of nitrogen. So again, another dinitrogen. And 5 oxygen. So penta is my prefix. But the next word is a vowel as well, oxide. So we drop the A and add the oxide. So drop one of the vowels, drop the vowel on the prefix and add it to your word. So dinitrogen pentoxide. And that is how we name covalent compounds using those Greek prefixes. In summary, we talked about how covalent bonds are between atoms that are sharing electrons to get to the desired energy state. If that sharing of electrons is equal, we have a non-polar molecule. If that sharing is unequal, we have polar molecules where one end has a slight positive charge and one end has a slight negative charge. Lastly, we talked about how many electrons they're sharing. They could have a single, double, or triple covalent bond. Thank you for listening.